Hello everyone, I'm Yogesh Balaji. Today I'll be presenting our work, Revisiting Memory Replay for Large-Scale Continual Learning. This is a joint work with my collaborators at DeepMind. The objective of this work is to perform large-scale study of continual learning algorithms. We first demonstrate the effectiveness of experience replay in large-scale continual learning. We then propose compressed activation replay, a simple and scalable algorithm for continual learning. For large-scale continual learning, we use a taxonomy dataset. Taxonomy is a large-scale computer vision dataset consisting of diverse tasks ranging from surface normal estimation, depth estimation, reshading, etc. In sequential training, we are given a T tasks in a task sequence, and the objective is to train models in this sequence so that the models minimize forgetting and perform well across all tasks. Here, X and Y denote the input and outputs respectively for each task. To train our models, we use the following architecture. We have a shared encoder and T task decoders. Both encoder and decoders are convolutional neural networks. To evaluate our models, we use two metrics, forgetting and performance drop. Forgetting measures how the test loss increases due to the sequential training, and performance drop measures the performance of the final model trained in the task sequence relative to a multitask baseline. Lower these numbers, better is the models. So experience replay is one of the simple algorithms for continual learning. In experience replay, we store input and output samples in a replay buffer. And while training the models, we train the models using a combination of task loss and the replay-based loss. Now we benchmark different continual learning algorithms and compare it against multitask and SGD baseline. SGD baseline is training models sequentially without performing any continual learning. We observe that experience replay performs the best among different algorithms for continual learning. Even though experience replay is a very strong baseline, we observe that it suffers this issue called feature space drift due to the continual learning. To illustrate the feature space drift, we take a model which is trained sequentially in this task sequence, and we take the final model and visualize the features of each of the tasks in the task sequence compared to a model which is trained only on the respective tasks. We observe that while the feature space of the later tasks are well aligned to these baseline models, the feature space of earlier tasks experience a huge feature space drift. And we hypothesize that this feature space drift is one of the reasons for getting high forgetting effects in experience replay. To prevent this, we propose activation replay, in which we replay the activation maps in addition to the input-output pairs. So now, in addition to the input and output pairs X and Y, we also store the activation maps F in the replay buffer. F is basically the output of the encoder network G. Now, while training the models, we train the models using a combination of three loss terms: the task loss, replay-based loss, and a feature matching loss. In feature matching loss, we match the activation maps of the current model with the activation maps stored in the replay buffer. And once we start using these activation replay, we observe that the feature space drift is significantly minimized. And even for earlier tasks, the feature space is well aligned with the baseline models. However, since we are storing the activation maps in the replay buffer, we incur memory overhead. To minimize this, we use compressed activation replay, in which we use a compression function that compresses the feature maps. We use spatial average pooling and channel average pooling as the compression function in our work. Now we show the results of our compressed activation replay framework compared to other replay-based algorithms on taxonomy dataset. We observe that our model achieves the best performance compared to other replay-based methods. We also obtain good performance on split CFR and split mean image dataset. To conclude, we first showed that experience replay is an effective strategy for large-scale continual learning. We then propose activation replay to minimize the feature space drift and improve the replay-based algorithm. And we also use compression techniques in activation replay to better improve the memory overhead. Thank you.